48 hours in advance of the storm. Even a small effect would have major benefits.
If you cool the water by 2 degrees, that could reduce the intensity of a hurricane by 50%. 2 degrees, 50%. So if you had a Category 5, you would end up with a Category 3. A 3 would go to a 1. That's enough weight on there, enough buoyancy.
The scale of the plan is audacious.
You're not going to be able to stop a hurricane with a squirt gun, so you need many, many of these pumps. We would probably need 200,000 pumps. For one hurricane, it would probably be $100 million to do this.
Skeptics point out that even if the enormous cost could be met, problems remain. Cold water is heavier than warm water. Would it sink back to the depths too quickly to effect the hurricane? Or would the storm simply switch from the cold patch onto a new hot patch and threaten a new region?
You know, hurricanes can change course and even double back on themselves very quickly, so I don't really understand how this technology can be moved around.
Look.
But Blumberg is convinced the details can be worked out with time and further research.
Come on, make me 200,000 of those. And you throw them out the back of a plane.
Technology may allow us to divert an asteroid and alter the path of a hurricane. But what about a supervolcano?
A super eruption is the biggest explosive eruption that we encounter on this planet.
It has the capability of erupting so much material, it will alter the Earth's climate in significant ways.
It sends out enough ash and debris to cover almost an entire continent. It pumps out something like 500 cubic miles of debris.
Still not completely understood, scientists believe that super eruptions are caused by boiling magma bubbling up from the Earth's core through hotspots, cracks in the mantle. As magma continues to rise, the area becomes more and more crowded. The pressure builds until it's simply too much. There are dozens of known hotspots around the globe, but no one knows exactly how many there really are. One of the largest of all lies directly underneath Yellowstone National Park in Wyoming. If it ever blows, the effect will be catastrophic.
When a super eruption first starts, you will have a huge blast of ash and debris right to the edge of space. And then a lot of that material will come back down again. It will spread out sideways, forming these hurricane blasts of ash and gas called pyroclastic flows. Now that would devastate an area probably as big as a small state.
The first blast is likely to shoot out of a ring of vents. The intact ground at the center of the ring crashes violently into the space vacated by the magma, and secondary, more powerful eruptions result.
So you may see this explosive eruption occurring at lots of different points around a sort of circular structure, and that will carry huge amounts of ash and debris right across the continent.
Half of the United States would be covered in up to a meter of deadly ash. That would mix inside human lungs like cement. A chemical veil would scatter sunlight back into space and block out the warmth of the sun around the entire planet for years. Crops would fail, livestock would die. Machinery, cars, aeroplanes would all clog and jam with ash.
There's never been a super eruption within historical times. The last one was probably about 30,000 years ago. But The one that happened 75,000 years ago clearly had major impacts on the world's climate and probably contributed, or possibly contributed, to a near extinction of human beings.
That super eruption carved out a 90 by 130 kilometer wide hole over 500 meters deep in Sumatra. Centuries of rain have filled in what is now Indonesia's Lake Toba.
There's a suggestion by some anthropologists that the effect of that eruption was to wipe out almost all humankind. So there may only have been a few hundred or a few thousand people left for several hundred years. Now, we certainly wouldn't see that again with a future super eruption, because there are now about 7 billion of us on the planet. But if you have a global harvest failure, then you may definitely see a number of billion people die as a result.
The first necessary line of defense is to be able to predict a super eruption. How well can we ever hope to do that? One of the world's most sophisticated ground monitoring systems is installed here at Yellowstone National Park. It offers the best clues to the restless activity below. A plume of hot and partly molten rock reaches as far as the state of Idaho to a depth of over 600 kilometers. Above it, the Yellowstone magma chamber stretches 65 by 40 kilometers across, 8 kilometers deep, reaching up to within 6 kilometers of the surface. Tiny earthquakes are normal and constant as the magma boils the groundwater above it, forcing it through the ground and up in the form of geysers. David Menson is the senior engineer in charge of data collection.
So what we're seeing here is the last 10 minutes. These little earthquakes are most likely related to the West Thumb geyser basin. There's a lot of geysers going on over there. It's not magma.
The last 3 super eruptions of the hotspot under Yellowstone have occurred at intervals close to 600,000 years. It's been 640,000 since the last one. And geologists have discovered that the entire area is currently rising very slowly. Is it a sign that an eruption is overdue? Volcanologist Jack Lockwood is cautious.
The problem with the forces of nature that power eruptions is they can fool human beings. They can start to set up a pattern, and I think those patterns are set up just to fool volcanologists. So once the geologist says, I see the pattern, now I understand, now I'm ready to predict the next eruption, that's when the pattern changes.
So we simply don't know what to expect. If Yellowstone is ready to blow, we might see the magma chamber rise much higher and earthquakes grow in intensity. We may even be able to predict an explosion months or years ahead. But what would we do if we ever got warning of an imminent disaster? Could future technology limit the damage of a future eruption? Surprisingly, we've already tried by attempting to control lava flows. Lockwood has experienced many efforts at lava diversion, including work at Mount Etna in Italy.
It's like a battle. You have to continually modify your battle plans in terms of what's going on.
In 1992, Etna erupted, threatening the town of Zafferana. Lockwood stayed in close contact with his Italian colleagues.
This was a 24-hour, 7-days-a-week operation involving hundreds of people.
The team tried to keep the lava high on the mountain by creating a holding pool out of a large uninhabited gully. They dropped concrete barriers directly into the lava to block the flow. But the lava simply swallowed up the concrete, setting it on fire. Next, the explosives team blew a huge hole in the path of the lava. The flow turned the lava away from Zafirana. The town was saved. It was one of the most successful lava diversion efforts ever. Lava diversion is possible on a small scale, but the quantity of lava from a super eruption would dwarf any attempt to contain it. If we can't stop the massive amount of lava and ash that would spew from a supervolcano, is there any way to prevent it from erupting in the first place? Some have suggested that setting off small explosions would relieve pressure and diffuse a supervolcano.
I get a lot of emails from people saying, can't we bomb Yellowstone, nuclear bombs, to trigger an eruption before it's, before things really build up, before the pressures really build up? How do you get your bombs into the magma reservoir? You'd have to drill holes several kilometers deep at a depth where the temperatures are going to be extremely high and probably high enough to trigger the bombs going off in any case. And then what would happen? You would probably trigger the eruption itself.
Others have suggested a different approach. Just like a hurricane, a volcano is fueled by heat. Could we somehow draw off the heat from the magma chamber, reducing the built-up pressure and diffusing the cause of the eruption? In principle, at least, there might be a way. This is the Puna geothermal power plant on the Big Island of Hawaii. It churns out 30 megawatts of power, about 20% of the island's needs. It does it by siphoning heat from the magma chamber of nearby Kilauea, possibly the most active volcano in the world. So could we cool down a volcano in this way? Drilling to such extreme hot depths is difficult, but not impossible. Drill bits would have to withstand extreme heat. They would have to cut through the toughest rock. That's what the engineers at Puna already do.
The drill bit and the drill string are all kept cool by pumping mud down the hole, and then the mud comes to the surface. We drill to about 4,000 to 6,000 feet. It's about a mile down in the earth, and the temperatures are between 550 and 650 degrees Fahrenheit at that depth.
The Puna Group has plans to increase output in the coming years. What if the project was expanded on a huge scale? Since the system draws off heat from the Earth, could 1,000 geothermal plants siphon off enough heat to cool a supervolcano magma chamber? The idea of hundreds of thousands of drilling sites destroying the pristine beauty of Yellowstone is not an appealing thought. But if the future of civilization were at stake, would it be worth a try? We could try, but we would fail.
You would need hundreds or thousands of these geothermal plants to do that, because you're talking about maybe 200, 300, 400 cubic miles of magma in the case of a super eruption. It would take an enormous amount of time to cool that down.
The amounts of heat that mankind can impact are absolutely trivial. Best way to lessen the risk to human beings is to be able to educate the public. Educate the public so when warnings are given, they're willing to evacuate.
In the end, our best plan of action would be to prepare evacuation plans for millions of people and to stockpile food for nations for years. Not even the most advanced future technology we can imagine would be able to prevent or predict a super eruption. In the future, technology may help us to prevent our extinction at the hands of an asteroid or a comet. We may even be able to tame hurricanes. But supervolcanoes are likely to remain beyond our reach.
Working around volcanoes most of my life, I'm ever humbled by the realization that man's power is very insignificant compared to the powers of nature. Someone said that Mother Nature always bats last.
And alter the path of a hurricane. But what about a supervolcano?
A super eruption is the biggest explosive eruption that we encounter on this planet.
It has the capability of erupting so much material, it will alter the Earth's climate in significant ways.
It sends out enough ash and debris to cover almost an entire continent. It pumps out something like 500 cubic miles of debris.
Still not completely understood, scientists believe that super eruptions are caused by boiling magma bubbling up from the Earth's core through hotspots, cracks in the mantle. As magma continues to rise, the area becomes more and more crowded. The pressure builds until it's simply too much. 48 hours in advance of the storm. Even a small effect would have major benefits.
If you cool the water by 2 degrees, that could reduce the intensity of a hurricane by 50%. 2 degrees, 50%. So if you had a category 5, you would end up with a category 3. A 3 would go to a 1. That's enough weight on there, enough buoyancy.
The scale of the plan is audacious.
You're not going to...
Onto a new hot patch and threaten a new region.
You know, hurricanes can change course and even double back on themselves very quickly, so I don't really understand how this technology can be moved around.
Look.
But Blumberg is convinced the details can be worked out with time and further research.
Come on, make me 200,000 of those. And you throw them out the back of a plane.
Technology may allow us to divert an asteroid.
Be able to stop a hurricane with a squirt gun, so you need many of these pumps. We would probably need 200,000 pumps. For one hurricane, it would probably be $100 million to do this.
Skeptics point out that even if the enormous cost could be met, problems remain. Cold water is heavier than warm water. Would it sink back to the depths too quickly to effect the hurricane? Or would the storm simply switch from the cold patch